Good morning, welcome to Frontier Labs Southeast Asia and India YouTube channel. In today's video, we will be introducing gas chromatography working principle briefly. As you all know, there are two most popular separation techniques that is available in the market. One is gas chromatography, the other one is liquid chromatography. Gas chromatography is used to separate volatile organic or inorganic compounds from a mixer where gas is used as a mobile phase. Liquid chromatography is used to separate non-volatile organic compounds from a mixer where a liquid is used as a mobile phase. So we can say gas chromatography is a separation technique for the separation of different volatile organic compounds from a mixer. The instrument that is used to separate these compounds is called chromatograph. Then the output data what we obtain from the instrument is called chromatogram. Gas chromatography is a premier technique used for the analysis of volatile organic compounds. You can introduce gas or liquid or even solid sample into a gas chromatography system. Generally, it is used for small molecule analysis. Separation is occurred at the column because of partitioning or adsorption-desorption process. We will be talking about it in a separate video. The most influencing parameters are the carrier gas choice, carrier gas flow rate, column, and temperature of the GC oven. Gas chromatograph consists of different blocks. The most important one is the carrier gas. Helium is the most commonly used carrier gas. In some application, nitrogen is used. Now recently people are trying to use hydrogen gas as well. So there is a flow controller that allow you to look at the tank capacity. Also you can set the flow rate for the instrument. Then this is the injection port where the sample is injected, and this injection port is set at high temperature that will allow the sample to get volatilized. Then it will be pushed to the column by the carrier gas where then the separation will occur at the column. Then these compounds are eluted one by one. This order will be depending upon the boiling point of the compound and the partition coefficient of the compound. Each compound will produce certain type of signal depending upon the type of detectors we are using. So this response can be recorded in a chart recorder or a software. The final output is called chromatogram. The type of peak in terms of the intensity and the retention time refers to different type of compounds and the concentration. This animation video can explain a little more about the working principle of gas chromatography. So what you see here is a stationary phase. Then you have a mixture of products that are being taken in the injection or sample introduction tool. Then it is loaded where it gets volatilized. Then the carrier gas or the mobile phase will push these compounds into the stationary phase slowly. So depending upon the partition coefficient, these compounds will be moving one by one, which can be collected in separate basket. This is what exactly you are seeing. So we had a mixture of red, yellow and blue balls. Now you are able to see them separately. That's another video that can give you a better explanation about it. So when you inject the sample, then the compounds from the sample is being separated and they are reaching the detector one by one. then it gives you the output. So this is what we call it a chromatogram. So you can see this is a sample that is injected into the injection port. So after volatilization, this volatile compound is coming to the column where the separation is occurring. Then it produces a different signal depending upon the type of compounds present in the mixture. So the take-home message: gas chromatography is a separation technique to separate volatile organic compounds from a mixture. In GC, we can analyze gas, liquid, even solid sample that are soluble in some solvent. Carrier gas, injection port, separation column, GC oven, detector and recorder are important blocks of GC. Column temperature, carrier gas and carrier gas flow rate are most influential parameter to influence the separation of compounds from a mixer. In next tutorial we will learn about the different type of GC detectors, and after that we will also learn about the capillary columns, including the ultra-alloy metal capillary column that is produced by Frontier Lab. Thank you.